So a football is punted at a 37-degree angle above the horizontal with a velocity of 20.0 meters per second. If the punt left the punter's foot at a height of 1 meter above the ground, how far did the football travel in the horizontal direction before hitting the ground? So we want to know how far this ball went horizontally. Well, to know how far it went horizontally, we can use this, right? We would need to know the starting vertical or horizontal velocity, and we would also need to know how long that went for, okay? So that's the trick. We got to figure out this time, okay? So let's draw a diagram, okay? So here's my X or my Y and my X axis, okay? So this is level ground right here. This is 0. So this is where he kicks it from, and he's kicking it at a 37-degree angle. So he's kicking it up like this. And this is definitely not to scale, okay? Now, it's not gonna land, and that's why I picked this problem to do. It's not gonna land right here. It's gonna land 1 meter below this, right? It's gonna, here's the ground level right here. Okay, so it's gonna go below where we kicked it off at, okay? And that makes this problem a little bit harder, okay? All right, so we know, what we know is it's coming off in this direction, and that the velocity it's going in that direction is 20.0 meters per second. And that's my V sub O, right? 20.0 meters per second. Okay, so I can break that up and get my horizontal velocity, my V sub X, which is what I'm gonna need. All right, so V sub X is going to equal, and I didn't write this, but I do know it. This angle right here is 37 degrees because it comes off his foot at a 37-degree angle above the horizontal. That's the horizontal right there. So we know that this is going to be 20 meters per second cosine of 37 degrees. So putting that into our calculator, 20 cosine 37, that's 15.97. So this is equal to 15.97 meters per second. All right, so now I can also get this vertical velocity right here, right? Okay, so that vertical velocity right there is V, starting vertical velocity is V sub YO, which is equal to 20 meters per second times sine of 37 degrees. And then we could put that into our calculator. And we get 12.04. Okay. So to get the horizontal distance, I'm going to need to know how long this was in the air. Okay. So X is, we're going to use this equation. X is equal to V sub X times time. So we need to know how long was the football in the air. Okay. And that's what this time is. Okay, so now I've got to figure out, okay, this time. Okay, so I know my horizontal velocity is 15.97 meters per second, and I'm going to multiply that by the time, right? So I need this right now, okay? So I need to figure out the time. Okay, now right here, Y is 0. Right here, Y, it's starting at Y sub O is equal to 0. It's ending right here, okay? And what is the Y coordinate right there? What would that be? Well, it's 1 meter below where he kicked it. So this Y right here, that point right there, is Y is equal to -1. All right? So that means I could go back and I know my initial vertical velocity. I don't know my time here. I know this is -1. I know my acceleration vertically is -9.8, and I have t squared. All right. So what that means is I can use, because I know, I know y is equal to -1. I know v sub y, comma o is equal to 12.04 meters per second. All right. And I don't know time. That's actually what I'm trying to find. Once I find this, it's going to go right in here. I know my a sub y is equal to -9.8 meters per second squared. Okay, so I can plug, I have all of them in for this equation except t. Okay, so I have or I should write this, y is equal to v sub y comma o times t plus 1/2 a sub y times t squared. So that means this y is -1. V sub y sub o is 12.04 times t. I'm not going to put units on this because you're going to see y in a minute. And then plus 1/2 a sub y, which is the -9.8. And then times t squared. All right, cleaning this up because I can multiply 1/2 times -9.8. This becomes -1 is equal to 12.04 t minus, because that's positive times a negative, minus 4.9 t squared. Okay, so what we have is a quadratic, and we're going to have to use a quadratic formula for this. That's why I gave you this, okay? Do you see how we can rewrite this so it looks like this? I'm going to move both of these terms over to this side over here, okay? So this becomes 4.9 t squared minus 12.04 t minus 1, and it equals 0. Okay, so in my formula, if at squared plus bt plus c equals 0, then t equals, okay, and you just got to put your a's, b's, and c's in, right? So in this case, your a is 4.9, your b is -12.04, and your c is -1. So that, we're just going to put everything in. You don't have to have this formula memorized, okay? So t is equal to -b, so that'd be 12.04. Plus or minus the square root of b squared. So that'd be -12.04 squared minus 4 times my a, which is 4.9, times c, which is -1, all over 2 times a, which is 4.9. Okay, so this is going to give me two answers, a positive value, and I think it's going to give me a negative value. Okay, so we're going to put this into our calculator. First, create the fraction bar, and then 12.04, and then plus, and then square root, and then parentheses, and then you got to use it when you're squaring a negative value. You got to use parentheses. Okay, I'm going to zoom in a little bit so you can see this a little bit better. Okay, so this is -12.04 squared, and then minus 4 times 4.9, and then times -1, all over 2 times 4.9. So just put it all in your calculator all at once. And so you get 2.54 seconds. Okay, you could type all of that again, or you could just go up, and I'm going to copy it and change this plus right here to a minus. So I'm going to go on top of it and press minus. And you get this -0.08. Okay, so this one doesn't make sense because it's negative, okay? We started the stopwatch right when he kicked or punted the football, okay? So we know, okay, this took 2.54 seconds, okay? That's pretty good hang time for football, okay? All right, so now we're going to come back here. Now that we know that's 2.54 seconds, we can come back here and say, oh, this is going to be, he's going to go this velocity for 2.54 seconds, and then it's going to hit the ground. Okay, so that got a little smudgy. So 12.97 meters per second times 2.54 seconds. So the horizontal distance is going to wind up being 15.97 times 2.54 and 40.56 meters. A meter is about it's kind of close to being a yard. So 40 yards, that's a pretty good punt. Okay. All right. So I try to do this so it comes out realistic numbers. Okay. Like that's a number that could happen. Even a high school student could punt at 40 yards. Okay. All right. So it's not like NFL or anything like that. Okay. So how far did the football travel in the horizontal direction? Okay. So the football traveled horizontally 40.56 meters. Okay, let me slide it up. Okay, so you're going to have a couple problems on your homework that deal with where you're landing below where you kicked it. Okay, or where you release the projectile. Okay, you're going to have a couple problems like this where you're and when this happens, just so you know, when this happens, you're going to have to use a quadratic formula because you're going to wind up with a y value right here. Okay, and you're going to have to get it equal to 0 and then use the quadratic formula. Okay, I don't expect you to factor anything because you're going to have decimals. Okay, for values. All right. Okay, guys, that's how you launch. That's how we launch projectiles at an angle. All right, and how you solve problems involving them. All right, you guys, that's it for today.